So if you're using hotspot, no need to use your internet. But if you're using ordinary internet, please turn on your camera. Let's start the class. Dora is here, Rachel, Alyssa, Katie, Emily, Sophia, Genesis, Masood, Josephi, and Lisa. Okay, so did you do your homework? I keep asking you, please do your homework. It's very important to do your homework because this is a very fast-paced class. And if you don't practice, you do not learn. Very important. Okay, so just fix my screen and then we can start the class. Okay, so because of the internet issue, I don't push you to turn on your camera. Okay, so we're going to continue about these functions. We are talking about graphing functions today. We are going to cover functions transformations and its applications, and then we talk about inverse functions, graphing, and more next time. Okay. So we want to talk about the graph of the function. You are already very familiar with this if you just look at a line. One of the very simple examples that I can talk about when we talk about graphing functions is linear functions. By, let's say, any linear functions you're all familiar with. Let's say, I don't know, 2x plus 1. So we want to look at the graph of this function, how we do this. So basically, we usually, if you are the beginners, we usually ask you to draw a few points to draw the graph of this function. We start with by taking a few points and finding the corresponding y's. For this one, this is linear function. You know that for a line, if you're familiar with lines, you know that you only need two distinct points to draw a line, right? If you have two distinct points, you can draw a line. So for that reason, especially I knew and I already know this is a linear function of this form and it's just equation of a line. The equation of a line, I already know I only need 2 points, but if you didn't know that, you have to take a few points, draw it and guess it. So let's take just 2 points, distinct points. When x is 0, 2 times 0 plus 1 is 1. When x, let's say, is -1, 2 times -1 is -2, -2 plus 1 is -1. So I have 2 points, so I can start drawing it easily, right? So it's very easy to draw. So just take the xy axis. And then you look at these two points, 0 and 1, x is 0, y is 1, which is here. And then it's -1 and 1, roughly. This is another point, so you have the 2 points. So you can join them to find the graph of this function. So this was easy, right? This is y equal to f of x equal to 2x plus 1, and I needed only 2 distinct lines to draw the graph of this function. Is it clear so far? This is so easy, right? But not always life is easy, right? This is the simplest, one of the simplest graphs that you can draw. How about quadratic functions? It's a very important. I keep saying quadratic functions are very important, so I'm going to focus on quadratic functions for today's class. Okay, before we go to quadratic function, if I ask you what is x-intercept here, do you know what's the meaning of x-intercept? X-intercepts or x-intercept, it depends on the function. Anyone knows? No? Yes, Sophia, you are correct. So the x-intercept basically means the intersection of the graph with the x-axis. So when your function intersects the x-axis, this is at this point, what this point is. To find the x-intercept, okay, so let's just write down x-intercept is the point, or is the is the point on or it can be more than one point, so I'm going to put s inside parentheses. So is the point on the x-axis which intersects the graph of the function. I should have said the other way. The graph of the function intersects this point of the function, or which intersects, or which passes through, right? Passes through this point. So for our example, if you're asked to find the intercept, find the x-intercept of y equal to 2x plus f of x equal to 2x plus 1. In other words, you want to know what this point is exactly. So to find exactly, just so what you just said, you just let y equal to 0 to get x, right? So you let y equal to 0. So you get 2x plus 1 equal to 0. And then from here, you get the x. So x is negative 1 over 2. So this point is exactly negative 1.1 over 2. So our x-intercept, we have only one x-intercept for this function because it's 1 to 1. And it is the point negative 1 over 2 and 0. Okay. Okay, so how about y-intercept? Okay, first of all, I'm going to ask you, y-intercept basically means the intersection of the graph with the y-axis. Okay. Okay, the point where your graph intersects the y-axis, it's called y-intercept. So maybe it's a good idea to write it first. Its definition: y-intercept is a point where the graph of a function intersects the y-axis. Okay. So for example, here is just 1, right? You see it? Because it's the point, this point, 0 and 1 is the point where your function intersects the y-axis. I have a question for you. Do you understand what is y-intercept? So my question is, let's write it. Can we have more than one y-intercept for the graph of a function? Yes or no, and why? Everyone think about it for a few seconds. Just imagine it and tell me why. Okay, everyone think about it. All right, let's see who is correct. So I got a few answers already. Uh, Joseph, what do you mean vertical line? So we talk about the function, okay, Joseph? Uh, Emily, you're correct. So it's intersection with the y-axis. Emily is correct. Sophie, Emily is correct. Sophia, exactly. Sophia, you're correct too. Yeah. So imagine. So the answer is no. Let's see why. Okay. So let's see why this is the case. Imagine you have a function. Okay, I'm going to draw it here. The point is that we have a function, right? So if you have a function like this, so you have more than y-intercept, you have 3 intercept. Is this a function? No, right? Do you remember vertical line test? Even if you don't remember vertical line test, imagine you have 2 points. Let's say this is -1, this is 2, and this is 3, just example. So your function passes through the point 0, -1, 0, 2, 0, 3. For one input, you have 3 outputs. Is it possible? No, right? Because a function, for every input, you have a unique output, right? It cannot happen. This cannot happen because for every input, we have a unique output. So y-intercept is always unique. If exists, it is unique, right? If there is a y-intercept, it is unique. But x-intercepts can be more than one. You will see in more examples when I introduce more examples. You will see that you can have more than y-x-intercept, but y-intercept is, if exists, it is unique. Okay, so far so good, everyone? Okay, so what is y-intercept here in our example? So I'm going to write down the y-intercept in our example. To find the y-intercept, you just let x equal to 0, right? So if I ask you find the y-intercept of the same question, then this to find the y-intercept, so you let let's just do it here, you let x equal to 0 this time, so you get y equal to 2 times 0 plus 1, which means it is 1. So this means that our y-intercept in our example, as you can see from this graph as well, it is the point 0 and 1. So your x-intercept is -1 and 1 over 2 and 0, and your y-intercept is 1 and 0. Is it clear, everyone? Any questions? Any comments? Is it hard? So easy, right? Okay. So now you are familiar with the x-intercept and y-intercept. It's very useful. X-intercept basically means it's intersection with the x-axis. So you let y equal to 0. So you usually, the x-intercept, also there is another word for the x-intercept. It's called roots, zeros. Okay, so let me just write down this terminology here for those of, maybe I will write it in the next page because then this is too messy. Okay, I will wait for you to take notes, please. And before I go to the next slide. I was thinking of this Roger outage. Imagine for a few, like if you do not have internet and no phone, or
I think Fido doesn't work either.
Fido is, yeah, is connected to Rogers. So imagine if there are, for a few days we do not have internet and no phone. Do you know what you have to do to contact each other?
We eat the rocks.
How we contact each other? I mean, how you contact your friends? You have to write letters, right?
No, I think there's a faster way. You make a campfire, and then you can like put like a blocker, so you can use the smoke.
I mean, contact.
Yeah, you can use
talking.
you use the smoke as Morse code.
Oh, that's so much fun. I mean, to say something, if you want to contact and say something, you have to write letters. You have to go back to 1980s. And but the problem is that we cannot even go back. Do you know why? Because if you write letters, you have to go to post office. And I don't think post offices works without internet. Even sending letters, we cannot go back to old days.
I
So
mean, the landline phones work.
Say it again. What, land phones? I don't think land phone. I mean, imagine even land phones doesn't work, right? So it's going to be very hard time. So hopefully this never happens. But if it happens, I think the whole world would be, oh well. Okay, anyway, it's going to be hard. Okay, so now let's go and do more questions. Let's start with with quadratic functions. I'm going to start with very simple examples and a few examples, and I'm going to generalize this. If you understand these quadratic functions today very well, you would be very good in quadratic function. Okay, so I'm going to look at any quadratic function in this. I mean, if I give you any quadratic function, you are able to find its graph, its properties, its maximum or minimum, anything about it. Okay, so please listen carefully to my class so you are very good at this point. Okay, so let's start with a very simple example. Let's say I have this function. So this is my example I'm going to do. So this is called quadratic function. Where A, B, C are given. Real numbers are given real numbers. It can be any number, any real number, okay? And of course, I'm assuming A is not 0 because if A is 0, then you do not get a quadratic function. You just get a real function, right? Linear function. You get a linear function. I'm assuming I want to look at quadratic function. So coefficient of x squared, I'm assuming is not 0. Okay, knowing this, let's go and see some examples. It's a good idea to divide my, it's easier. Okay. So let y equal to f of x equal to, let's very simple one. Okay, so I'm going to say very simple one, x squared minus 2x minus 8. Okay, so this is a quadratic function, right? It's this form. Your a is 1, your b is -2, your c is -8. Okay, let's see how I'm going to do it. So in general, okay, so let's just write it here. If your coefficient of x squared is positive, the graph is going to be parabola opening up, okay? And if a is negative, the graph of function is going to be parabola opening down. At least you have to know this up to this point. So what I'm going to do the graph of this function. There are a lot of ways to graph this function. Okay, so there are a lot of things I'm asking. Graph the function, graph the function, find x. Okay, so just I forgot to tell you, x-intercepts. Okay, there are a lot of people forget this and keep asking me in the test day, what is zeros, what is roots? X-intercept means zeros, the same terminology, or roots. They're all the same thing. Okay, x-intercepts, roots, zeros, they are the same. They're all the same thing. Okay. Okay, graph the function, find x-intercepts and y-intercept. Find the minimum or maximum. Where this is a parabola because the coefficient of x squared is 1, right? So it's a parabola opening up. If it's a parabola opening up, then it has a minimum point, right? Find a vertex. I will explain what is vertex at very soon. Okay, so let's start. Usually the first thing it's good to do when you want to graph quadratic function is to see if you can factorize it. Okay, so if you can factorize it, or in other words, if you can find its roots or zeros or x-intercepts, it helps you to do the graph very fast, usually. Okay, let's try to see if it works. So can anyone factorize this? X squared minus 2x minus 4? Anyone knows how to do it?
Oh, the quadratic formula.
Okay, do you know how to factorize this?
Oh yeah.
Dora did it already. Sophie did it. Kaylee did it. Very good. So you all know. So it's basically, you look at 8, negative 8. Negative 8 is 2 times negative 4. And 2 plus negative 4 is negative 2. So 2 and negative 4 works. This means that I can factorize my function as x plus 2 times x minus 4. Okay. Do you guys understand this? Okay. Now I factorize, then it's easy to find x-intercepts, right? Usually when you want to graph a function, it's usually good to know the x-intercept, y-intercept, and so on. So to find x-intercepts, you let y equal to 0, right? So you can just see it, y equal to 0. So this is a 0 because we already found it, wrote it in a factorized form. So it's very easy to find its x-intercepts. So x is negative 2 and x is 4. So my x-intercepts are negative 2 and 0 and 4 and 0, right? So easy. So once I got x-intercept, you can also try to find y-intercept by letting x equal to 0. So you can put it in the original equation. If you put x equal to 0, you get negative 8. So y is negative 8. So my y-intercept is 0 and negative 8. It's always good to find this because it helps you to draw the graph easily. Okay, so good. And I also know that the coefficient of x squared a is 1, which is positive. So I know that I'm going to get a parabola opening up. Okay, so this is a very good hint. Okay, so far so good, everyone. All right, what else is good to know here? Okay, now let's try to look at the graph. Okay, listen to me carefully to see how I'm going to proceed, okay? So I start with x-axis and y-axis, of course. Okay, so far so good, right? No problem. Now, I think these points that I have already. So x-intercepts are negative 2, which is my zeros basically, and 4. Okay, I know my graph is going to pass through these 2 points. And then I have y-intercept, which is 0 and negative 8. 1, 2, 3, 4, 5, 6, 7, 8, roughly, right? So I know my graph is going to pass through these 3 points. Now, the most important part that I'm going to tell you to be able to finish drawing is the following. Okay, if your quadratic function has 2 distinct roots, or has 2 distinct x-intercept, which is the case here, we have 2 distinct zeros, -2 and 4, right? If you got that and they are distinct, what you have to do is find the midpoint of these 2 numbers. What is the midpoint here? Where is it? How do you find the midpoint? The point which has the same distance from -2 and 4. Emily says 1. How did you get it? 4 plus -2 divided by 2, right? That gives you the midpoint, right? So it's 2 divided by 2, which is 1. So this is my midpoint. Okay, so this is my midpoint. I'm trying to change my color. So this is my midpoint, right? Okay. So far, so good? Did you understand so far how I got this point 1, x equal to 1? Okay. Now I'm going to find f of 1. What is f of 1? You can put it either here or here. 1 minus 2 minus 8. 1 minus 2 is -1, minus 8 minus 9. Right? Now let's find -9 here. -9 is here. So 1. I got another very important point. -8 -9. So I got another very important point. Now I have 4 points, but this is the most important point here. How I got it? So I just find the midpoint of these 2 points, and then I found f of 1. So I have a 1 and -1. This point is called vertex. And in our example is the minimum point. You will see why. Now I'm ready to draw the graph. I already know my graph is a parabola opening up. And once you have the vertex, you're almost done. So I'm going to draw it, roughly speaking. My graph is going to look like this. Right? So it's smooth. I try to draw it smoothly, but it's smooth, right? There is no sharp point here. So it's very important to know that. So why this is called vertex? The point where the maximum or minimum occurs is called vertex of a parabola. So if your parabola looks like this point is called vertex. If it is like this, then this point is vertex. Okay, so this is very important. And the line x equal to 1, the line x equal to 1, which is this line, right? This line. So you can draw it if you want. It's this line, right? Draw it properly. Well, so I'm doing very badly. So this line x equal to 1, right? This line x equal to 1 is called the line of symmetry. Can anyone tell me why? X equal to 1 is called the line of symmetry because your parabola is very symmetric with respect to this line. Half of a parabola is to the right of this line and half of a parabola is to the left of this line, and it's very symmetric. Whatever you have to the right of this line, you exactly have it to the left of this line. It's symmetric with respect to this line. Okay? Is it okay, everyone? Is it clear? Any questions, any comments? Okay. So you see, if you can find the zeros of a parabola, then it's going to be very easy to draw it. Because once you have the two x-intercepts or the zeros or the roots of your parabola, then you find the midpoint. And then once you found the midpoint, you find f of that midpoint. F of that midpoint gives you the vertex, and you're done. But once you have the vertex, you're almost done. You just draw it, right? So it's very easy. So the case, this is a very interesting case. And how did you know that? Because one is the midpoint of, yeah, exactly. One is the midpoint of the two x-intercept. That's why I found f of one. That's why I say this is the vertex. Okay. I'll stop. Okay, everyone. Okay, please make sure to take notes. This is a very important topic, so I want you to learn it very well. Once you learn it, this, like all these remarks and all these important facts, you do not miss anything about quadratic functions. For example, if I ask you what is the domain of this function, of course it's x. There is no restriction for x. You may say it's immediately it is R, right? Right? How about the range? Can you tell me what is the range of this function? Now you know that it's graph. It's very easy to tell me the range of this function. What is the range of this function? To know the range of the function, either you need to know the graph of the function or you need to know the vertex of the function of this, I mean, this quadratic function. Anyone? What is the range? Okay. Kaylin, very good. Sophia, very good. A2, no. So the range is the image of the graph, right, on the y-axis, the shadow of the graph on the y-axis. Do you see any shadow, Beitun, here? If you look at the shadow of your graph on the y-axis, do you see any shadow below -9?
No.
No, right? So there's no below -1, there is no y, there's no x, right? There's no y. So this means the range of f actually is, it's above -9, right? It's above -9. It's -9 and plus infinity. In other words, it's just y larger than equal to -9. Where did I get -9? -9 is the point where my vertex is, right? So maybe before today's class, you were not able to find the range of a quadratic function, right? But now you all know how to find the range of a quadratic function. Louisa Zhang, why are you with 2 accounts? Could you please remove one of the accounts? Louisa Zhang. I have to remove one of them if you don't remove it. So can I remove one of them? Okay. Oh, okay, you already did. Okay, thank you. Okay, who needs more time to take notes? No one? Raise your hand if you need to take notes or write it to me if you don't have camera on. Okay. So I'm going to do another one. This time you are going to do it for me, okay? So I want you to do it. I want to answer all these questions that I ask here: x-intercept, y-intercept, vertex, domain, range, all of them. Answer for this example. Let y equal to f of x equal to negative 2 times x minus 1 times x plus 5. Okay, find everything. Graph f, find x-intercept and y-intercept, find the vertex, find range of f. Yeah, everyone do it. Let's see who can do it. I'm going to call your name to see if you're done. One minute. Okay, so I'm mostly interested in the vertex and also the range. It's very easy to find out. Okay, B2 answered. Very good, B2. Okay, more people. What is the range? What is the vertex? I'm looking for vertex. Joseph, you made a mistake in the range. Okay, so let's see how to do it. It's a very easy question. Oh, once you load the previous question, this question is going to be very easy to do it. So this is already in factored form, so you know it has two roots. So basically you can find the zeros or the roots or the x-intercepts by letting y equal to 0. You get x equal to 1 and x equal to -5. So these are my roots. So my x-intercept are basically 1 and 0 and then -5 and 0. And then my y-intercept, basically you let x equal to 0. So you get, you let x equal to 0 and you get, I'm just going to write it down. When x is 0, you get -1 times -2 is 2. 2 times 5 is 10, right? Once you get this, and now I told you that we can start. So your coefficient of x squared is -2, right, Joseph? That's what we're using. So the coefficient of I haven't seen the range. So the coefficient of x squared is -2, which is negative number. So I know it's going to be parabola opening down. So now I'm almost ready to draw the graph of this function or this parabola. So again, you start with 10, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. So this is 10. So my y-intercept is 10. At 1, your function is 0. And then at -5, 1, 2, 3, 4, 5. It's a rough graph, so you're not expecting to get too much from it. So now it's time to look at the midpoint of -5 and 1. So -5 plus 1 divided by 2 gives you the midpoint, which is -4 divided by 2 is -2. So the midpoint is -2, so which is here. So once you got x equal to -2, you get f of -2, which is -2 minus 1 is -3, -2 plus 5 is 3. So it's 18. So 2, wow, I can do it. I have to do it properly. My numbers are not nice. So 1, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is my vertex, right? No, this is not my vertex. This is 18. My vertex is -2 and 18, right? So let me just do it again. 1, -5, 2, 4, 5. -2 is the midpoint. 1 is, these are my vertices. Okay, so now your function passes through the -2. And 18, this is my vertex. So, and what else I need? Yes, and I also have 0 and 10, which is here. So you're almost done. So it's a parabola opening down. So let's do it. Help me, please. It's so hard to do it. It's very narrow, so that's why it's hard. I can do that. Okay, so you do it. It's like this, right? It's a very symmetric and very nice. It's not like up and going down and up. So it's very smooth function. Like this. Anyway, so this is the function. The vertex is given now. So the range is very easy to see. The range is 18 and -infinity. So, oops, why did I write down like this? So the range is basically y less than or equal to 18, which means it is -infinity and 18. Your vertex, again, and let's repeat it. Your vertex is -2 and 18. So basically knowing the vertex helps you to know the range, but you have to be careful. You have to also know the sign of A because it tells you that is it going up or down, because that's where I know this is less than or equal to 18, not larger than equal to 18. So yeah, so Emily got some of them correct. And Sophia, you don't range, you don't write like this, you write -infinity and 18, not 20. Why did you write 20? Yeah. Any questions here? Okay, We're going to have in total less than 15 minutes break. Let's go for 5 minutes break and come back. Okay, come go and grab water, go washroom, come back very fast. Okay, 5 minutes. 5 minutes gone. Please turn on your camera. Everyone turn on your camera. Let's continue. So we talked about parabola, but these two examples that I gave you had two roots, right? Two distinct roots, right? So if your parabola has only one root, how it looks like, right? That's the question we want to answer as well, right? So you have to be able to do all these different cases. So let's look at one example. Let's say I want to do this one, 2 times x minus 1 square. I don't want to focus on roots, how to find the roots of a quadratic equation. I believe some of you already know. If you don't know, you learn it. That's why I give in a form that you can see that it has only one root, right? Okay, so this is my function f of x. The same questions I do not want to write. Please write it. The question is graph f, find x-intercept, y-intercept, and find the vertex, find the range. The same question. Okay, think about it for a few seconds and see what happens. What do you think the graph looks like? It has only 1, 0. A parabola like this has only 1, 0, or like this. How can this happen? Can anyone tell me? Where is the vertex? Very good, Kelly. Good notice. Good notice. Good notice, Beitu. You're also correct. So imagine this is your x-axis, right? The x-axis. This is your parabola, and this is your parabola. It doesn't matter. And you want to put the x-axis here. The x-axis cannot be here, otherwise it has 2 roots. The x-axis cannot be here, otherwise it has no roots. The x-axis has to be exactly on the vertex, right? It has to be tangent to the vertex. That's the only way you have only 1 roots, right? So, right, everyone, do you understand what happened? Okay, so in the case, if you have only 1 root for your parabola, for your quadratic equation, that root is exactly your vertex. So then everything is almost finished. So let's do it. Solution. So I didn't write down the question. This is the same question as the previous 2 questions. So solution. So my vertex is going to be, or let's just say zeros, x-intercepts. I will let y equal to 0. So x is equal to 1. So I have only one x-intercept, which is 1 and 0. 1 root means that the x-intercept, this is only for quadratic, this rule is only for quadratic functions, not for anything else. Remember that. X-intercept is the vertex. Very good. So this is also good. So your coefficient of x squared is 2, which is positive. This means that my parabola is opening up. This is also very important to notice. So you may try to give just some points to do this question now. Let's just try to draw it. And then let's just do the y-intercept as well. Y-intercept. Let x equal to 0 and you get y equal to 2, right? So the y-intercept is basically 0 and 2. So let's draw it. The point 1 and 0 is my vertex. I have another point here, 0 and 1, 2. This is another point, right? And then I know my graph is going to look like this, right? So you know the line of symmetry, right? Based on the vertex, you know, my vertex is based on the vertex, I know that the line of symmetry is basically the x of the x coordinate of the x-intercept, right? Symmetry is basically the line x equal to 1, right? I know that this line is the line of symmetry, right, everyone? This is my line of symmetry. Why it's helpful? Because I know whatever I draw here, it's going to be here, and I already know it's opening up. So I can try to draw it, or if you need one more point, it's not a bad idea to find at this point, right? It's a line of symmetry. So whatever you have here, you must have here as well. What is this point? If this is 1, this is 2, right? So this is 2. At x equal to 2, your y is in fact 2. So I know, I can see from the graph, and also I can see from the formula this is the case. So I'm ready to draw the graph. Yes, just imagine it's very smooth. So this is the graph of a function. Let's just change the color. Okay, so this is y equal to 2 times x minus 1 squared. We have to cover the transformations. Any questions so far? Oh, the range. So the range is very easy to see from, you can see from the graph and also see from the vertex. The range is y larger than or equal to 0, which is basically 0 and plus e. And you can also see from the formula as well. It's very easy. For this question, at least, it's easy to see the range. Okay, so the only thing is left is the case when you have no roots, right? No roots. The way that I'm going to do for the case no root also works for these two cases. So the last case is very general. You can use this method, the last method that I'm going to tell you today, to draw any quadratic function. Can I go to the next page? Okay. So the last case, let y equal to x squared minus for x plus 5. Okay, so you may ask me why I know this one doesn't have any roots. There are a lot of ways to see that. One of them is to use, anyone who knows what is discriminant delta? B squared minus 4ac. Wait, when did you learn this?
Delta means like the difference.
Oh, no. I'm talking about this formula. Do you remember b squared minus 4ac formula?
Isn't that just the quadratic formula?
Yeah, quadratic formula. Have you learned it?
Yeah.
Where?
TT Math.
TT Math, which course? Which number?
E.
Yeah, discriminant. E? What do you mean by E?
Level 2E.
Level 2E. Okay, good. I wanted to just, yes, Joseph, you're correct. That's called the discriminant. You can use the discriminant and b squared minus 4ac here, which is negative 4 squared minus 4a is 1, c is 5, and this is simply 16 minus 20, right? 60 minus 20 is -4, which is negative. This means no roots, no real roots. Anyone is not familiar with this? With the discriminant delta? Who is not familiar? Okay, if you're not familiar, please go and look at the internet or your book or your previous notes. Okay, anyway, so we know there is no real root. So if you have a parabola that has no real root, so then your x-axis cannot intersect the graph, right? So your x-axis either is below that, right? It's like this, cannot be below that, right? For this one, because it otherwise intersects. So it has to be above the vertex or below the vertex, right? The x-axis, right? Because it has no roots. For that reason, so what do we do to find the vertex? No roots, because so if we have two roots, the midpoint of the two roots helps us to find the roots. If you have one root, then that's exactly the vertex, right? That point. But if you have no roots, where's the vertex, right? To answer this, you use perfect square method. Okay, so try to write down your functional, let's call it f of x, in terms of, in this form, which is called a perfect square method. So basically you're trying to write it to make it in perfect square form. In other words, completing the square, that's what we are doing. We complete the square. How you do it? So I have told you in other levels how to do it. Basically what you do, you look at coefficient of x, which is -4. You divide, and you look at the coefficient of x, which is -4. You divide by 2 and then you square it. What do you get? You get -2 squared, right? Again, I look at coefficient of x, I divide it by 2 and then I square it. I get -2 squared. Now what I'm going to do, I'm going to add this number and subtract this number from my function. So add it, subtract it. Adding and subtracting means I haven't changed my function, right? I added and subtracted this guy. Now, look at this one. I believe everyone can recognize this. This is exactly x minus 2 squared, right? And the rest, this is -4 plus 5, so it's 1. So I wrote down my function in this form. Do you see it? If you write down your function in this form, which you can actually do it for all the previous questions that we did, you can also do it this way. Always works. But I wanted to learn that way because sometimes it's faster to do that way. If you write down any quadratic function can be written in this form, then h and k, the point h and k is the vertex. Okay, and x equal to h is the line of symmetry. Is the line of symmetry. Okay, so you can do it this way. So now I have ready. From here, I can see that my h is 2 and my k is 1. In other words, my vertex is 2 and 1. Your a is 1, which is positive. So I know it's a parabola opening up. So I have the vertex. I know and basically once you have the vertex, you can do everything you want. And so also let's find the y-intercept by letting x equal to 0, you get 5. So it's 0 and 5 is my y-intercept. So you have everything ready. Let's do it. So the point is 2 and 1. So x vertex is 2 and 1, which is here. And I know it passes through the point 0 and 5, 2, 3, 4, 5. So it's symmetric. So you can guess it, or you can just try to give another point easily by just going forward. I'm sure it's going to be here. So you can draw a nice parabola. passing through this point and this point, and this is my parabola. As you can see, it never intersects my x-axis because it has no roots. So the range, easy. Once you have the vertex from here, you can get the range of that f because it's a parabola opening up. So it's above 1. So y larger than or equal to 1 is the answer, which is 1 and plus infinity, and we can see it here as well.
Is it possible to have a parabola that never touches the y and the x-axis?
Parabola always intersects the y-axis, right? So you just give x equal to 0.
But isn't it like possible to make like a parabola like this?
No, that's not parabola.
Oh.
That's not even a function, right?
Oh
This
yeah,
is-
right. That's not a
This is
function.
not a function, right? Okay, so let's just go to vertical line test. Did I tell you vertical line test last time? I did? I don't think so. Let's just do it. So then, so the question is how to check if the given graph is the graph of a function. So you are not given the formula, instead you are given a graph and you are asked to see if it is a function or not. To answer this, you can use a vertical line test. Vertical line tests, basically it says, okay, let me just explain it with the graph. So let's say x-axis, y-axis, okay? So if you are given a graph, it doesn't matter how this graph is, okay? So if you are given any graph, let's say this one that Beitu mentioned, and you want to know if this is graph of a function or not, basically what you have to do is take any vertical line, okay? So take any vertical line and so this vertical line, okay? So this vertical line doesn't intersect my graph, right? Right? Now I'm going to move this vertical line as much as I want to the left and to the right of this graph. So if I move it to the left, nothing changes because my graph is not to the left of this line, it's to the right. So let's just keep moving this line, this vertical line. I keep moving it, but I have to make sure it still is a vertical line. Move it, this vertical line, vertical line, vertical line. Okay, once you get into a point where your vertical line intersects your graph at 2 points or more, then you can say this is not the graph of a function. In other words, if you find at least one line, one vertical line that intersects your graph at more than 1 point, then it is not the graph of a function. So here, for example, let's say this is 4, and let's say this is just, I'm just giving points here so you understand what's going on here. So let's say this is 3 and this is 4, and let's say this is 5 and this is 4. So at x equal to 4, your function is mapped to, at x equal to -4, sorry, -4 is mapped to 4 and also is mapped to 5. In other words, this is not a function, right? Why? Because of the vertical line test. So there is a vertical line that intersects your graph at more than 1 point. Therefore, it's not a graph of function. So what is vertical line test? Finally, vertical line test if every vertical line intersects the graph at most means either it doesn't intersect or it intersects at one point, then the graph is the graph of a function. But if there exists only one, if you can only find one vertical line, if there exists at least one vertical line that intersects the graph at more than one point, then it is not the graph of a function. Okay, is it clear? So this is in fact not the graph of it's not a function because you found one vertical line that intersects the graph at more than one point. But if I give you another one, okay, so take notes before I go to the next slide. Okay, can I go to the next page? All right, so now you guys tell me which one of these are functions. Okay, so I have this circle. Is it a circle? Does it look like a circle? Is this a function? And I have this one. And I have this one. Okay, let's start with the first one. Is it a function? No, because just take the vertical line, right? If you take this vertical line, it's enough you just show me one vertical line. This vertical line intersects my, just give me 1 second, x, y axis, x, y axis, x. So it shows me that it intersects my graph at more than one point, therefore not a function. How about this one? Is it a function? The second one. Yes, because if you take any vertical line, if you move this vertical line along, it always intersects the graph at most at one point. So the answer is yes, it is a function. How about the last one? No, right? So easy to see. You have plenty of lines, vertical lines that intersects your graph at more than 1 point. For example, this one. Even the y-axis is also another example. The y-axis intersects your graph at more than 1 point as a vertical line. It's not a function, therefore. Is it clear, everyone? Yes? Okay, let's go for another 6 minutes for break and come back, okay? See you in 6 minutes. All right, let's go. Turn on your camera, please. Is it already 5 minutes? I forgot. Or maybe less than 5 minutes. Okay, turn on your camera. It's not less. It's not 5 minutes, Kaylee. How many minutes is it? Okay, everyone turn on your camera. Rachel, are you here? Let's go. Let's continue. So I talk about vertical line test. Let me give you one more example of graph. We'll just draw this one. And yeah, so just give me 1 second. This is 1, 2, and then I go 1, 2. Three, and then 3, and then so my graph starts like this, goes to this, and then goes to this. All right, so the question is the following. A, find, this is a graph of y equal to f of x, find f of 2. B, okay, find f of 2 first, everyone. Okay, so it's f of 2 is basically, you just look at here, is 3. Find f of 3. Okay, do it. Wow, I'm getting different numbers. Be careful. Okay, so I'm going to do it. F of 3, according to this example, it's on the x-axis, so it's 0. So f of 3 basically means f of 0. F of 0 is x equal to 0 is 2, so it's 2. Now f of 3 is f of 2, which we already got it, so it's 3. Done. So the answer is 3, not other thing that you just put down. Okay, so this is nice. So we are done with this. Okay, so let me go to the next topic, which is about transformations. So what is transformation of two numbers? So basically, I want to answer a few I want to transform. Imagine you take your graph of a function and you move it up without changing it. Just shift it 2 units up, or just take it and shift it 2 units down, or shift it 3 units left, right. how did you do this with formulas, right? Imagine this is, for example, the graph of y equal to f of x equal to x squared. Okay, and I'm sure everyone knows the graph of x squared. This is one of the parent functions. I always ask students to memorize its graph. And then I ask you find the graph of y equal to x squared plus 3 using the graph of y equal to x squared, right? So I'm sure you already know it. So in general, if the graph of if the graph of, in general, y equal to f of x is given, then the graph of y equal to f of x plus k is obtained by shifting, or it's called translating, the graph of f k units up if k is positive, or k units down if k is negative. That's basically you need to remember for the translation by k units down or up. For example, let's do this one. So for our example, we all are familiar with the graph of y equal to x squared. Okay. So the graph of y equal to x squared is simply, those of you who have internet, please turn on your camera. So this is what you have, right? So this is y equal to x squared, roughly, right? So now I want x squared plus 3, so I have to just shift it 3 units up, right? So you are going to just, this is 0, so you're just going to shift it 3 units up. So you're going to just exactly the same thing, you just shift it 4 units up. So you don't change anything. It's exactly the same thing, just shift it 4 units, 3 units up, right? So this is the graph of x squared plus 3. This is a rough graph, okay? But you got the point. So if I want to look at the graph of x squared, let's say minus 2. So I shift 2 units down, right? So let's do this one. So example, this is, I don't really, okay, so I don't open it up, I just do the same thing. I don't stretch it, okay? I just do exactly what I have, just put it down. So this is x squared minus 2, right? Everyone understand this? So this is very easy, right? So this is translation k units. It's called vertical translation by k. Vertically, you're moving your graph vertically, right? Up or down. That's why called vertical translation. How about horizontal translation? So what if I have y equal to, let's say I have the graph of y equal to f of x, and I want to look at the graph of y equal to f of x minus h. So this is called horizontal translation by h. Remember, this is minus h, okay? So this is very important. Some students get confused. this is minus h, we say horizontal translation by h. So what do you think? What happens to the graph of f if you translate, if you change your graph, your function from f of x to f of x minus h? Anyone? Yes, it's horizontally shifting right or left, right? So y equal to f of x minus h is obtained by shifting or moving the graph of f h units right. So it's right if h is positive, or left if h is negative. Okay, so let's see example. Again, let's just look at our simple example, y equal to x squared. So, or you can just look at any function. Let's just look at the function. I'm not sure if you're familiar with that. Do you remember the graph of absolute value of x? Anyone remembers absolute value of x function? So this is the graph of absolute value of x. Now let's do this thing. X minus 1, let's say. Absolute value of x minus 1, your h is 1, which is positive. So you go to the right. Let's say this is 1. So you draw the same thing. You basically shifted 1 unit to the right. So it's going to be so it's not going to change anything. It's just you are just shifting it 1 unit to the right. So this is the graph of f of x minus 1, which is basically the absolute value of x minus 1. Right? How about x minus 2, x plus 2, let's say, or 3, let's say 3, x plus 3. X plus 3, right? The absolute value of x plus 3 basically is absolute value of x minus 3, which is basically f of x plus 3, right? So your h here is negative, which means you have to shift it to the left 3 units. So I'm going to shift it to the left 3 units. So let's use the color. So it's exactly the same thing. You're just shifting. Nothing changes. So it's just shifting it. So this is the absolute value of x minus 3, which is basically the absolute value of x plus 3, which is x basically absolute f of x plus 3. Is it clear, everybody? Any questions, any comments? Is it hard? I believe you're all already familiar with this, right? Aren't you? Okay. So how about this one? It's called vertical compression or stretch. So what it is, basically you have the graph of y equal to f of x, and you are looking at y equal to a f of x. Of course, assuming that a is not 0. What do you think, everyone? What happens? just give me 1 second. Do something. Yeah. Okay. So it's called dilation as well. That's correct, Kaylee. So it depends on A. Assume that A is positive for the time being. I will talk about negative later. So assuming that A is positive here, so what this is, you're multiplying F by the whole thing by A. So what happens is you're, you look at my hand, I'm talking about vertical, okay? Imagine whatever you have, like imagine you have a circle. Circle is not a function. I want you to learn what I'm doing. A, based on A, if A is larger than 1, it's vertical stretch. So you stretch your graph, okay? If A is less between 0 and 1, it's compression. You compress it, okay? It's like you're pushing it. So if A is between 0 and 1, it's a vertical compression. And if A is larger than 1, it's vertical stretch. Okay, so let's see what do I mean by that. So let's just see examples. Examples are always good. What example is good for stretch? Okay, yeah, so let's just do this one. Let's say this is my my function. It's a function, right? So whatever it is, this is my function y equal to f of x. Okay, so I want to look at y equal to 2 f of x, 2 times f of x. Basically, you have to stretch it vertically. Remember, if it is on the x-axis, 0 times anything is 0, so it doesn't really move. So you cannot stretch it. You are taking it out, but it doesn't move from it. It's like it's attached to the x-axis, so it doesn't change the point where it is on the x-axis. So you're shifting, you are vertically stretching it by multiplying by 2. So what do you get? So let me change my color. So it's going to be stretched twice because it's 2. So this is going to be y equal to 2 f of x. So it's stretched vertical. So if it's less than 1, for example, let's say 1/3 f of x, let's do it another color. So you're basically compressing it, right? So it's going to be, roughly speaking, it's going to be like this. So this is the graph of y equal to 1/3 f of x. You are compressing it, right? Is it clear, everyone? Okay, please take notes before I go to the next page. Can you go to the previous page for a second? Yes, Alyssa. Okay. Are you done, Alyssa? So the next page. Everyone take notes, please. Okay. So I'm going to go to the next page. Is it okay to go to the next page or you are taking notes? So let me know. Need time? Raise your hand if you need time. Just put your hand up if you need time. No one? Okay. Yeah. You just put your hand up whenever you want. Okay, Emily needs more time. Okay, good. If you remember, I didn't talk about negative a, right? So I'm going to talk about negative a separately by just looking at the graph of y equal to f of x and going to y equal to negative f of x. What do you think what happens to the graph of f? Anyone? Reflection, yes, reflection in x-axis actually. So it's a reflection in about x-axis. Okay, so let's see it. Very easy to see this one. For example, let's say I have the graph of, it can be anything. So let's just put this one. Color. So this is my parabola, whatever it is. I don't care. It's I just want to look at minus f of x. So it's a reflection in x-axis. So whatever you have to just reflect it. So it's going to be whatever you have distance. So let's do exactly the same thing. So yeah, so this is minus f of x. This is x-axis and this is y-axis. Is it clear? Okay. And another thing you can do is to mix them up, put them all these operations together, right? So you don't have to do every operation separately. You may have mixture of them all together. Okay, before I go, okay, make sure everyone take notes before I go to the next page. Okay. So you can go from the graph of y equal to f of x to graph of y equal to a f of x minus h plus k. I don't make it, I didn't talk about horizontal compression. We'll talk about it later. But this is what we have. So you can put all these two all together, right? So what happens to the graph of f if you want to do this one? So you have to go slowly. The order of operation is very important. Go from here to here. So first you start with stretch. And you wake up, the first thing you do is to stretch, right? Right? So stretch first. That's how to remember. So let's do vertical stretch first. Vertical stretch by A. So if assuming by absolute value of A, if it's A is positive, if not, just look at absolute value of A. So you do the vertical stretch, and also if A is negative, you also do if A is negative, you also do the reflection in x-axis, okay, at the same time. So it's going to be A f of x. This is the first step you do. Next, it doesn't matter which one you do it, then you can do vertical translation by k. So you get y equal to a f of x plus k. And then finally, you do horizontal translation by h, which gives you this one, right? So you go all the way to here to get this graph. Okay. Okay. So we did this transformations. Let me sure I covered everything I needed. Okay, so now let's do together, everything together. Okay, so let's look at one example of doing all this together. Okay, as I told you, the order is very important. You cannot do the, for example, you cannot do the vertical translation and then do the stretch. If you do, you will get something else. Okay, this is very important. This order, stretch must be done first, otherwise you get something else. Okay, so let's see one example. Let y equal to f of x equal to, so we did this kind of graphs before without translations, without these transformations, but I want you to do using transformations. We already saw how to do this question, right? The vertex is 1 and 3, for example, right? And then you can draw it. It's a parabola. You can do it very fast. But let's try to use transformations to do this. Draw the graph of f using transformations of y equal to f of x. So y equal to x squared. Okay, so let's do it. So okay. Do you want to do it by yourself? I give you 1 minute to do it before I do it. Do it, everyone. 1 minute. Okay. Kaylee, good. You did the stretch first. Yeah. Okay, so you can graph it without looking at any intercept, right? So let's do it. So I'm going to do it first, stretch, right? Vertical. So let's draw the graph of y equal to x squared first. We already know how it looks like. So roughly speaking, this is the graph of y equal to x squared. Now I'm going to do step by step by using transformation. Vertical stretch by 2. So means is vertically I'm stretching by 2, right? So it's stretching it, right? Vertically stretching it. So you have to just stretch it. 2 is so everything is going to be doubled. Basically, it's y. So roughly speaking, this is what you're going to write. It's a rough graph, right? Because it's a parabola, that's harder. So this is y equal to 2x squared by 2, which I get y equal to 2x squared. Next, I'm going to do vertical or horizontal, it doesn't matter which one. Vertical translation by 2 by 3. I have to go 3 units up, right? So if this is 1, 2, 3, so I take the green graph and take it 3 units up. So it's hard to draw it, so I'm just trying my best to do it. I'm not sure if they intersect. So then, oh, 3 units, sorry. 3 units, so it has to be like this, right? This is 3. You shift your green graph 2 units up, and finally 1 unit to the left, vertical, horizontal, 1 unit to the right, sorry. Horizontal translation by 1, which means I go 1 unit to the right. So I get, this is for 1, so it's, so I have to shift this one 1 unit to the right. So I'm going to get this one. Again, this is a rough graph. This is graph of y equal to, so this is y equal to 2 times x minus 1 squared plus 3. And this is the graph of y equal to 2x squared plus 3, which is this blue graph. And the pink graph is 2 times x minus 1 squared plus 3. So you can try to find the y-intercept. So it's x equal to 0 is 5. So this must be 5. Okay. Is it clear how we did this question? So you can do plenty of this kind of questions once you have the parent functions. That's why sometimes we look at some parent functions. For example, we need to know graph of y equal to x squared, y equal to absolute value of x. Yeah, root x, remember root x 1 over x, or even an exponential function that we're going to learn in this class. All this, so if you remember the graph of these functions, so then you can do any transformations of these functions easily by using the transformations that we learned today. Okay, I guess that's it for today. I finished all the thing I needed to finish. Please make sure to do your homework. Okay, so this is a very fast pace. To do your homework, attend the homework class to make sure you are doing correct in your homework. And I will see you on Monday. Okay, bye everyone. Go to the previous page.
Bye.
Bye.
Thank you. Bye.
Thank you. Bye.
Thank you.
Thank you, Alyssa. Bye.